The question we are solving now belongs to test series 9. It is of network theory subject. In specific, it belongs to DC network solution methodology. As per the question, there is a DC electrical network given as shown in the figure. It contains two current sources of currents I1 and I2. The current source I2 has a resistance R1 in parallel, and the current source I2 has a resistance R1 in parallel, and the current source I1 has a resistance R1 in parallel, and these two sources are connected by a resistance R2 as shown. The voltage across the R1 is measured as VO. It is given that VO is equal to R0 multiplied by alpha I1 plus alpha square I2. We need to find out alpha and R0 in terms of R1 and R2. So from the given electrical network, by using the superposition theorem, let us find out the V0. When the current source I1 is acting alone, the equivalent circuit can be drawn as shown. The circuit contains two resistors R1 and R2 and the current source I1. Please note that the current source I2 is replaced by open because of the reason that the current source I2 has a infinite internal resistance. From this we see that V0 can be written as I1 multiplied by R1 plus R2 divided by 2R1 plus R2. Please note that whatever we have written just now gives the value of the current through the R1. So this should be multiplied by R1 to get V0 dash. Now let us draw the equivalent circuit when the current source I2 is acting alone. And when the current source I2 is acting alone, there is a resistor R1 connected in parallel with I2, and there is another resistor R2 and R1 as shown. Please note that in this case the current source I1 is replaced by open because it has infinite internal resistance. So in this case V0 double dash can be written as I2 multiplied by R1 plus R2 divided by I2 multiplied by R1 divided by 2R1 plus R2. This mainly gives the current through the series combination R1 plus R2, and this should be multiplied by R1 to get the voltage across the resistor R1, which is V0 double dash. From this we see that V0 can be written as I1 multiplied by R1 plus R2 multiplied by R1 divided by 2R1 plus R2 plus I2 multiplied by R1 square divided by 2R1 plus R2. Let us compare this expression of V0 with R0 multiplied by alpha I1 plus alpha square I2. Upon comparison, we see that alpha R0 can be written as R1 multiplied by R1 plus R2 divided by 2R1 plus R2, and alpha square R0 can be written as R1 square divided by 2R1 plus R2. So this is by comparing the equations that we have marked just now. Now upon dividing 2 by 1, we see that alpha can be written as R1 divided by R1 plus R2, and upon substituting for alpha in 1, we see that R0 can be written as R1 plus R2 whole square divided by R1 multiplied by 2R1 plus R2. So by using the superposition theorem, we got the expressions for alpha and R0. Hence the correct option is D.